Hey everyone, I'm Angie, and today I'll be teaching you how to sense temperature using a totally new component called a thermistor. A thermistor is a resistor that changes its resistance with temperature. And we're going to use it to change how bright an LED is. So the LED is going to indicate to us just how cold or warm it is. Let's get started. This is a thermistor. It's a type of resistor. Usually for resistors like these, you assume that the number of ohms is constant, but that's not actually always the case, because all resistors are affected by temperature. Resistors are always going to change their resistance the tiniest bit when the air surrounding them gets hotter or cooler. Now luckily, these resistors are designed to make that change due to temperature super minimal. But that's not the case with these guys. These are thermistors, which are resistors specifically designed to take advantage of the change in resistance with temperature. They're super sensitive, and they're made that way on purpose, so that they change their resistance a lot with temperature. Which means we can use thermistors to measure, you guessed it, temperature. The thermistor in your kit has a resistance of 10K at room temperature. When you make it warmer, the resistance will go down, but if you make it cooler, the resistance will go up. I can use this thermistor in a circuit in place of a resistor and pair it with an LED. If I warm the thermistor up, the resistance will go down and the LED will get brighter. Let's draw it, then build it. We draw a thermistor like a regular resistor. So we make a zigzag with an arrow through it at a diagonal. The arrow tells us that this is a special resistor that changes with temperature. I'll use it like a regular resistor in our LED circuit. So we have 5 volts to the LED, to the resistor or thermistor, and ground. The question is, when we change the temperature around the resistor, how much will the resistance change? For instance, let's say we have a 10K thermistor, and then I touch it with my finger, and it gets a little warmer, and its resistance decreases to 9K. That's a pretty subtle change in the amount of current that's going to go through the LED, and I doubt that I'm going to be able to see that change in brightness with my naked eye. But if the 10K goes to 1K when I touch it with my finger, I feel like I'm going to be able to see that change in the LED. Let's build it. So I've drawn it, I've got my parts together, and now we build. And now the moment of truth. I'll rub my hands together to get them warm, and then touch the thermistor. I guess that made the LED a little bit brighter, maybe? I want to figure out how I can make this thing get hotter so I can see a big difference in the LED. How do I do that? I'm just kidding. Please don't do that. We're going to find a better way. I'm going to use something else. Like my hairdryer. Success! Did you guys see that? It definitely got brighter. Now I've got these ice cubes to see if I can make it go the other way. Well, I just got water in the breadboard. I have no idea if that helped. Well, that was fun. I thought putting an ice cube near the thermistor would make it cooler and then would dim the LED, but instead I got water on my breadboard and it created a short. So I used my hairdryer to try to get the water off of it, and it didn't really work, so now I'm doing this. Luckily, there's a better way. Right now in Chicago, where I'm based, there's a polar vortex. So if I take this outside, I think the LED is going to get super dim. Let's find out. Is it drained? Everyone okay? So we see that thermistors are definitely sensitive to temperature changes. But right now, we need to either make it extremely hot or extremely cold in order to see any change in the LED connected to the thermistor. Later in this playlist, we're going to have videos that show you how to change this sensitivity and be able to see these slight changes in temperature a little bit better. Until next time, I'm Angie. Thanks for watching.